Section 2.3, this section, we talk about calculating limits using the limit laws. Okay, so there are several laws, okay, that we need to pay attention to. Okay, limit laws. Okay, all right. So let's look at these limit laws. Okay, suppose that c is a constant. Okay, and the limit of f of x when x approaches a, and limit of g of x when x approaches a exist. Okay, both of these two limit exist. Okay, then we have these laws. Okay, these are the very standard, common sense laws. Okay, so let's talk about them very quickly one by one. Okay, limit of the sum of the function equals the sum of the two limits. Okay, limit of the subtraction equals the subtraction of the limits. If we have a limit of a constant c times by f of x, we could multiply this c in front of the limit. Similarly, product, division. Okay, well here, the denominator limit of g of x when x approaches a cannot be 0. Okay, here this denominator cannot be 0. Okay, and then if we compute limit of the nth power of f of x, it will equals compute limit of the function then nth power of it. If we have a constant c, what is the limit of a constant c when x approaches a? Let's do a picture about it. This function f of x equals a constant c. How can we graph f of x equals c? Horizontal line, right? So this is what? F of x equals c. Okay, it's a constant function. Okay, constant function gives us a horizontal line, right, guys? Okay, it says when x approaches a, it doesn't say left or right. That means in both sides. So, for example, when a is here, x approaches a from both sides. What is the limit of c when x approaches a? Still c, right? Y value, which is the f of x value, is still c when x approaches a, because f of x is always c, right?
Yeah, there's no change.
No change. So that's why we have this conclusion. A limit of a constant number, a constant, okay, when x approaches a is always the same constant. Okay. Alright, now let's talk about limit of x when x approaches a. What should we have? X is a polynomial, right? X approaches a, or if you want to draw a picture, what is this means this is f of x, right? This is f of x equals x. How can we draw the picture graph of f of x equals x? Y equals x.
A 45-degree angle.
Yeah, this is straight line, right? Straight line. This is f of x equals x, where y equals x. Okay, so when x approaches a from both directions, how about the corresponding y value? Because y equals x, right? So when x approaches a, y also should be what? Should approaches to what? To a. Okay, so yeah, so limit of x approaches a equals a. Okay, well here, limit of x to the nth power, x goes to a, okay? Well, x to the nth power is what? It's a power function, right? X to the nth power, okay? For power function later, okay, you will see power function is a special case for what? Polynomial, okay? So for polynomials, okay, later we'll talk about the direct substituted property, okay? So when x approaches a, okay, for power function, because x, there's no limitation about x, okay? So when x approaches a, x to the nth power will approaches to a to the nth power, okay? Same thing for what? The nth root of x when x approaches a will approaches to nth root of a, okay? Well, limit we use equals, okay? And the limit of nth root of f of x approaches a equals nth root of limit of f of x. Okay, so these are the laws. Okay, these are the laws. Any questions about these limit laws?
Is it important we memorize all of these?
No.
These are, oh.
No. We go over this and then you know them, that's it. If there's something, very important, I will let you know in class directly. Oh, this is something very important. This may show in your exam. Please pay attention to it. Please make sure you memorize it. I'll let you know. If I don't say it, you know it. You don't have to memorize it at all. No. Okay? Alright, guys. So let's keep on looking at this property, okay, in our section, okay? It's called a direct substitute property, okay? So I'm going to ask volunteer to read this property for us. Let me see, whose turn? I called you, some of you guys before. Let me see. From the bottom. Nicholas?
If f is a polynomial or a rational function, a is in domain of T.
Okay. There's domain of f.
Limit f of x equals f of a as x approaches a.
Okay, very good. Thanks. Okay, let's look at this property is telling us. If function f is a polynomial function or a rational function, okay, so f is either polynomial or rational function. Do you still remember polynomial function? I'll give you an example. Okay, so a1 x to the n1's power plus a2 x to the n2's power and so on. Okay, so this type of function is called polynomials. Okay, polynomials. So these n's, they're what? Or I'm going to write it like this. This is not n1. This is n. This n2 is n minus 1. And then, the next term is going to be a3 times x, or the a to the n's, a to the n minus 1's, okay, blah, blah, plus a1 x to the first power plus a0. So this is a polynomial functions. Each term of the polynomial function is a power function. Okay, x to the nth power. an times x to the nth power is a power function. Okay, so polynomial function. What is the domain for polynomial function? Is there any restrictions about x?
All the numbers.
All the numbers. Yes, you're right. So there's no restriction for x. X could be all numbers for polynomial. Okay, so this x very good. Okay, no restrictions about x. Okay, so when we have a polynomial function, we want to come to the limit of a polynomial function. When x approaches to a constant a, what do? We just direct substitute x by what? A. Okay, so the limit of the function will be exactly equals f of what? A. Okay, for polynomial functions. Okay, or if f of x is a rational function, okay, what kind of function is called a rational function? If a function is defined by polynomial over polynomial, okay, so r of x is a polynomial, q of x is also a polynomial. Okay, now we know that for polynomial functions itself, the domain will be all real numbers. Okay, however, for rational functions, okay, let me make this to be g. Okay. Yeah, because we want to make sure that this function looks different from the previous function, okay? So let's make it to be g, okay? Well, for rational function, what is the domain for a rational function g?
Any number such that the lower polynomial doesn't equal 0.
Yes, okay? So rational function and the a is in the domain of f, okay, of g, okay, in this case, okay? So the domain for this function g is what? All real numbers, but except the what? Except those x, which will make the q of x what? Equal 0. Okay, so I would say q of x cannot be 0. Okay, so there is also some restrictions of x. Okay, but whatever polynomial or rational function. Okay, so when we need to compute a limit of these type of the functions, polynomial or rational functions, what do? We just use direct substitution property. Okay, so well here a is in the domain of f. What does that mean? A is in the domain of g means what? The a value will not make the q of x what? The q of a cannot be 0. Okay, then we direct substitute f, okay, x, okay, by a. Okay, we can get the limits. Okay, now guys, let's do these three examples. First one, evaluate this limit of this function 2x² minus 3x plus 4 when x approaches 5. What type of this function it is? Polynomial, right? So for polynomial to find the limit, what do we do? Yeah, we know the a value is what? 5, right? And if this is f of x, okay? If this is f of x, the limit of this f of x when x approaches 5 will be exactly what? F of what? 5, right? Okay, according to the property. Okay, so f of 5 means when x equals 5, what is this function, value of this function? So what do? Replace every x by what? 5 directly, okay? So 2 times 5 squared minus 3 times 5 plus 4. Can you give me an answer, please?
39.
39?
That's what I think, yeah.
2 times 25, 50. Follow the order of operations. Minus what? 15 plus 4. Then only subtraction multiplication, do it from the left to the right, right? 50 minus 15, 35 plus 4, 39. So, who got 39? Please hands up. You guys. Okay, everybody, okay? Alright. Good, thanks. Okay, so this is question A. So let's try question B. Find the limit of this function when x approaches to -2. Now, my question for you, what type of this function is? Rational function. What is the domain of this rational function?
3/5. Everything except 3/5.
Yes. Domain of the rational function is all real numbers, but x cannot be what? 5/3, right? Yeah.
You're correct, you're correct.
Okay. So because 5 minus 3x equals 0 give us 5 equals 3x divided by 3 from both sides. X cannot be 5/3. So that's the domain. All real numbers, but not this value. We want to calculate limit of x approaches -2. Our a value is -2. Is -2 in our domain? Yes. So we can do the direct substitute property directly. Okay. Say if this is our function f of x, okay, by using the direct substitute property, okay, or you can write it here, okay, dsp, okay, yeah, dsp, it gives us what? F of what? -2, right? Substitute x by -2. What?
-1/6, right?
-1/6?
I think so. You might want to, you can factor it out or something.
Everybody, do you agree with -1/6? Or do you have a different, no? What do you get? 1/11?
That's right, yeah.
-1/11.
-1/11.
That's right.
Let's try, okay? Yeah, let's try. So, -2 to the cube equals what? -8. -2 squared +4 times 2 +8 minus 1. On the bottom, okay, on the bottom we should have a 5 minus 3 times -2. Multiplication first, right? So 5 -3 times -2 give us what? +6, right? So 8 is gone, and then the answer should be what? -1/11, which is -1/11. So, right guys? Okay, so these two examples, have you noticed that one function is what? Polynomial, the other function is what? rational function, okay? So as long as, well, for polynomial, there's no restriction for x, okay? So we can use direct substituted property directly. However, for the rational function, we have to make sure that x approaches to this a must be in the domain, okay, of the function. Then we can also use the direct substituted property. Okay, so far so good? Okay, so this is this property.
What if -2 wasn't in the domain? Then what would you do?
I think that would mean that that limit does not exist.
Well, if this a value makes the denominator equal 0, but does not make the numerator equal 0, means we will have a constant c divided by 0. Then we say this limit does not exist because we cannot have a constant divided by 0.
Okay.
However, a lot of cases when we use x approaches a, this a makes both numerator and denominator equal 0. We'll have a 0/0 case. We cannot say this limit does not exist. Remember we had a couple of practice questions from the previous section?
Right.
When we have 0/0, it's undetermined. We should keep on determining the limits. Okay? Well, if we have a 0/constant, 0/constant equals 0. You have a constant over 0, this is what? Undefined. A 0/0, we don't know. We may have a limit, we may not. So we'll see.
I keep going.
Yes. But for this one, this a value is in the domain, so we don't have to worry about it. We just need to substitute the a value into the function f. Right? Okay, very good question, Simon. Alright, so let's turn to page.
Should you make a new video? Can you upload this one?
Absolutely.